Okay, everyone. Assalamu alaikum. I'm going to resume. So there was one question left when our last session ended. So we were done with part A of question number 5 and also almost part B of question number for this question as well. We have one question left after this. Now let's quickly complete this paper. So this is part 2. We are already done with the first 4 questions and the first couple of parts of question number 5 in the previous part already. You can find the first part in the playlist before this for the earlier questions. Now let's resume from here. So this was the question that we were looking at, question number 5. In the first part, we had to show that probability of x equals 2 equals 0.114. We had done that already. In the second part, we had to complete this probability distribution table, okay? And we already found the probabilities for x equals 0 and x equals 1. Now, if you want, you can find the probability of x equals 5 separately as well by thinking of all the possible scores you can have for that. In fact, there's only one possibility for getting 5 as well. And that will be when you have 2 wins and 1 draw, right? That's the only possibility to have a score of 5, right? 2 wins and 1 draw. That's this one. Now, this can come in 3 ways as well. You can have 2, 2, 1. You can have 2, 1, 2. And you can also have 1, 2, 2. All right. Now, in how many ways? What's the probability for this? Probability of winning was 0.5. So 0.5 into 0.5 into 0.3 for a draw, right? And then there are 3 cases like this. We multiply this by 3, and that will give us the result for this case of 5 as well. Now, if it's easy enough to do, I would recommend that you calculate it like this, because then you can verify your answer as well. If all of these numbers are adding up to 1, you can be pretty sure about your final answer that this is correct. Okay. If you subtract the rest from 1 to get this answer, then you can't verify your answers in that case. Okay. So if you calculate this probability directly like this, let's see what that turns out to be. 0.5 into 0.5 into 0.3 multiplied by 3, that's giving me 0.225. I can fill this table completely. And now if I add all of these probabilities up, let's see what I get from this. 0.008 plus 0.036 plus 0.114, 207, 285, 225, and 125. And that's giving 1. And that confirms that your working is correct as well. All right. So it's good to calculate it like this, because then you can verify your answers as well. That's part B. Now let's move on to part C. It says find the variance of x. You just have to use that standard formula for variance here. What's the formula for variance when you have a probability distribution table given? It looks like this. Variance of x is given by sigma x squared p minus expected value of x whole squared. That's the formula that you've got for variance given a probability distribution table. Now, the probability distribution table is already given, right? You've got x and you've got p. Now, what we need to do is we need to find the variance for this data. Now, in order to find the variance, we need sigma x squared p and also the expected value. How is expected value calculated? The formula for expected value is sigma xp. All right. So for variance, we need both the mean, both the expected value and the variance. Okay. Now, let's add to the table a couple of rows. One row will say xp and then another x square p. xp is just the product of these 2 rows. Okay. 0 into 0.008, that's 0. And then 0.036, 0.228. Let me just confirm this as well. 114 into 2, that's 228, 0.228. And then 207 into 3, that's 0.621. And then 0.285 into 4, that is 1.14. And then 5 into 0.225, that is 1.125. 6 into 0.125, that is 0.75. So you've got all the xp values here. Once you've got all xp values, now you want x square p as well. You can either square x and then multiply that by probability, or you can also just multiply xp with x. I'm sorry, I've done this mistake before as well. X and xp, you can multiply these two rows, and that will also give you x square p. All right, x into xp. What does that give you? 0, 1 into this, that's 0.036. 2 into 0.228, right? Because x into xp, that's also x square p, right? That's what I'm doing here. So what do we get? 2 into 0.228, that's giving me 0.456. And then 3 into 0.621, that is 1.863. 4 into 1.14, that is 4.56. 5 into 1.125, that is 5.625. And then finally 6 into 0.75, that's giving me 4.5. So we've got xp values and we've got x square p values. Now we need to evaluate sigma xp, sigma f, and then use them to find the variance. Okay. Now let's total these values. Sigma xp. Please confirm this calculation as well. 0.036 plus 0.228 plus 0.621 plus 0.1 plus 1.14 plus 1.125 plus 0.75. Okay. XP, sigma XP is turning out to be 3.9 for me. Please confirm that. 0.036 plus 0.456 plus 1.863 plus 4.56 plus 5.625 plus 4.5. That's 17.04. Is sigma XP also fine? 3.9? Okay, so that's turning out to be 3.9 for me again. I did that twice. Okay, now let's find the variance. Variance of x, what is that? Equal to sigma x square p, that is 17.04 minus expected value. What's the expected value? Sigma xp, that is 3.9. We just need to square that, and that will give you the variance. You can see what that turns out to be. 17.04 minus 3.9 squared, and that is giving me 1.83. That's the variance that we have here. If you wanted standard deviation, you could take square root of this, but in this case, you're just looking for variance, and that is your final answer. All right, so that's question number 5 done. Now let's look at the last one from this paper. That's question number 6. It says, a new village social club has 10 members, of whom 6 are men, 4 are women. The club committee will consist of 5 members. Okay, so you have 10 members in total, 6 are men, 4 are women. And you have a club committee that consists of 5 members. In how many ways can the committee of 5 members be chosen if it must include at least 2 men and at least 1 woman? In how many ways is this possible? Now, let's write that down here. How many men do we have in total? We've got 6 men in total. How many women? There are 4 women in total. Now, we have to make cases for this. What are the possible cases? So there have to be at least 2 men and at least 1 woman, and the total number has to be 5. Okay. Now let's start in order. So first of all, if we have 2 men, how many women would we have? 3. Right? If we have 3 men, we could have 2 women. And if we have 4 men, we could have 1 woman. And that's it, because we can't have less than 2 men, and less than 1 woman. So these are the only 3 possible cases that you get from this. All right. In how many ways can this be selected now? That's fairly straightforward. Out of 6 men, in the first case, choose 2, 6C2. And out of 4 women, choose 3, that's 4C3. 6C2 into 4C3, you'll get something from this. And then 6C3 into 4C2. And then finally, 64 multiplied by 4C1. And that will give you the result. You can see what these individual values turn out to be. 6C2 is 15, I think. 15 into 4, that's 60. 63 is 20. 20 into 6, that will be 120. 64 is again 15. 15 into 4, that will be 60 again. Can somebody confirm this as well? I think this was 240, right? 240, okay? Yeah, so we get 240 from this. Okay, let's look at the next part now. Now it says the 10 members of the club stand in a line for a photograph. So now they're standing in a line for a photograph. How many different arrangements are there for of the 10 members if all the men stand together and all the women stand together? Now all 10 members are standing in a line. The men have to be together, the women have to be together. What do we do when we have to put some people, objects, things together? We put them in one single box. Okay. Now we've got 6 men and 4 women. So we have 6 men here, M1, M2, all the way up to M6. Remember, they're all different. Similarly, we have 4 women. They're all different. W1, W2, up to W4. In how many ways can these boxes be arranged? First of all, there are 2 boxes, right? We can arrange the 2 boxes in 2 factorial ways or just 2 ways. And then in how many ways can we arrange the men? 6 factorial. And then in how many ways can we arrange the women? 4 factorial ways. And that should give you the result. Okay. That's 3, 4, 5, 6, 0. Yeah. So that's 3, 4, 5, 6, 0. That's the result that we get from this. Okay. That's the second part. Make sense? Now let's move on to the next part. It says, for a second photograph, the members stand in 2 rows. So now we're having another photograph, and now they're not all standing in a straight line. They're standing in 2 rows now. Okay. With 6 on the back row and 4 on the front row. Ollie and his sister Petra are 2 of the members of the club. So we have 2 sisters. How many different arrangements are there of these 10 members in which the sisters stand next to each other on the front row? Okay, so there are 2 rows. The front row has 4 people. Let's say this is the front row, 1, 2, 3, 4. There are 4 people. And the back row has 6 people, 1, 2, 3, 4, 5, 6. Now the condition is that those 2 sisters, they have to be in the front row, and they have to be together in the front row. So if they have to be together, what we can do is we can put them in a single box or on a single dash like this, so that they're together. Okay. Now, how many arrangements are possible of these 10 people? How do we figure this out? We have 10 people in total, right? Now, we also need to decide out of the remaining 8 people, who is going to be there in the front row and who is going to be there in the back row. Unless we know that, we can't do arrangement, right? So we first need to decide which of these people are going to be in the front row and which of these people are going to be in the back row. We need to decide that. Now, how can we do that? We have 8 remaining people. Those 8 remaining people, we need to select 2 of them and put them in the front row. Okay. So first of all, we have to do selection. We have to decide from the remaining 8 people. We have to select 2 to place here in the front row. That's 8C2. And then the remaining 6 people are, of course, going to be here. If you want, you can do 6C6 for that, but it's not required. 6 is just 1, right? So you can do that if you want, or you can just leave it like this. Now, once you do 6C2, now you know which of the which 2 of the 8 people, of the remaining 8 people, are going to be here in these 2 positions. 8C2 basically decides that. You could either do 8C2, or you could also do 8C6, as in decide which 6 people would be here, and then the remaining 2 people would be in the other row. You can do it either way. 8C6 and 8C2, they're both the same thing. They both give you the same result. So 8C2, what that's doing is it's deciding which 2 people are going to be here. Now, once that is decided, now you know which 2 people are going to be there. Let's call them X and Y. And then the remaining people, we don't know. Let's call them A, B, C, D, E, F. They're all different people, right? Now we need to arrange them. Now, in how many ways can we arrange these people in the front row? People in the front row, they can be arranged in 3 factorial, because there are 3 dashes. They can be arranged in 3 factorial ways. However, O and P, they could also switch their places. So we have to multiply by 2 factorial because of that. These are the people in the front row. We have arranged them. Now, what about the people in the back row? In how many ways can we arrange them? They can be arranged in 6 factorial ways. And that is going to give us the final result. You can see what that turns out to be. 8C2 multiplied by 3 factorial, multiplied by 2 factorial, multiplied by 6 factorial. And that is giving me 241,920. That should be the result that you get from this. Is that okay? Any problems with this? Why can't we do 8 factorial? Okay, so you are saying if we know that 2 people here are going to be O and P, then why can't we just do 8 factorial for the remaining people? If you do 8 factorial for the remaining people, your assumption is that O and P are going to be here in this first place. And you are saying the remaining 8 places are these 8 places. And in those 8 places, we can arrange the remaining 8 people. That does not make sense, because these 2 can also switch places with the other 2 people. Right? These 4 people have to be arranged together. If you do 8 factorial, so that would only be possible if you knew that OP were fixed here and they could not move. If OP could not move, then yes, you could say do 8 factorial for the rest of the people, right? Because we have 8 remaining places and 8 people, we could do 8 factorial for them. But their OP is not fixed. O and P are not fixed there, right? They can also move. Because of that, we first need to decide which 2 people are going to be there in the front row. Once we have decided that, then we can arrange the people in the front row separately and arrange the people in the second row separately. Yes, so if you, okay, so the other possibility, what you are saying now is, so you're multiplying by 3 as well, right? So, okay. So the other possibility that you are saying is, yeah, okay, so that makes sense. That makes sense. The other possibility is, you could say that you have these 8 places. You have these 8 places. They can be arranged in 8 factorial ways. However, then you also keep into account the possibility that OP can move around. Okay. Now, OP can move around in how many ways? It can be here, in this current position, or it can be here, or it can be here. So there are three ways of OP being there. So you have to multiply that by 3 because of that. And then O and P can switch places with each other. That will be 2 factorial. So yes, that could be another possibility, but then you have to make sure that you account for the possibility for O and P to be moving around as well. So there are 3 cases for that. And that could give you the same result as well, 241920. That could be another possibility. Okay. All right. So that's part C. And that's it. That completes this paper. That's all that we had to do in this one. Now, yes, Ali, you had any questions? You had some questions? You can let me know quickly the problems that you have. We could discuss them. And then we'll wrap this up. Did you message me earlier? Or was it somebody else? It was you, right? Yeah. Yes, so let me know what specific problems you have, Ali. So this paper is done, right? So that's all that we wanted from this. Ali, can you hear me? Okay, selection in this paper, question number 6, part A. Okay, and June 21, paper 5.3. June 21, paper 5.3, question number 6, part D. Okay. The difference is, here we're talking about letters. We're talking about letters here. The 3 E's that we've got, they're all identical. So we don't have to select, in the first case, for instance, 2 C's out of 3 E's. We don't have to do that because all 3 E's are identical, right? Similarly, the R's are identical. So we don't have to do 2C1 in this first case, for instance, for selecting 1 R, because they're identical. It doesn't matter which one of those 2 R's we select. In the question that we have just done, we're talking about people. Now, they're all men and they're all women, yes, but they're not all identical. All men are not identical. All women are not identical. They're different people. So out of 6, if we want 2 people, we have to select which 2 people we want out of 6. So when we have letters, they are identical. So we don't have, so if we have repeated letters, we don't have to account for their selection separately. Okay, we just only have to do it for the letters that are different, not for the identical letters. Does that clarify it for you? However, in this case, there are some problems in which you treat these letters as different. You need to remember that case as well. And that is when you have to find probability. I think it was June 2021 as well. We did that yesterday, did we? Yeah, this question. Then you have to find probability, and we have repetitions and combinations. In this case, you have to treat the letters as different because otherwise probability will not turn out to be correct, right? Because when you have identical letters, the probability of each outcome becomes different. In order to make it the same, we treat the letters as different. We talked about this yesterday as well, right? So except this case, when you have to find probability, in case of repeated letters, we do not account for the possible selections for those letters separately. All right? Okay, anything else? Okay, how do you adjust the gaps between intervals? If you have, for instance, an interval like this, 11 to 20, and then 21 to 30, and then you have 31 to 50, and then maybe 51 to 80. What you do is you have to adjust these intervals for drawing a histogram. Find the midpoint of these numbers, 20 and 21. What's the midpoint? 20.5. That's the actual cutoff point. Find the midpoint of 30 and 31. That's 30.5. And then similarly, here the midpoint of 50 and 51, what's that? That's 50.5. These are the actual boundaries. And then you adjust the sides on the same pattern as well. On the left side, you would say this is 10.5. On the right side, you would say this is 80.5. And then the gaps are adjusted. Then you can draw that histogram. All right. In the ungrouped data, what's the formula for the median? In ungrouped data, the formula for median is n plus 1 over 2. N plus 1 over 2. This is the position of the median. Then you find whatever that position is. Okay. If it turns out to be a decimal, for example, if you have 10 values, then you would do 10 plus 1 over 2. That gives you 5.5. 5.5 means you take the average of the fifth value and the sixth value. Take the average. You can use this for group data as well. Yes, this can be used for group data as well. But for group data, n over 2 can also be used, but this cannot be used for ungrouped data. So I would say use this for both. However, if you have a cumulative frequency curve, then you have to use n over 2. Then you can't use n plus 1 over 2. For a cumulative frequency curve, you have to use n over 2. For group data, both of them work. Okay. Anything else? One method for finding variance is formula. What's the other method? As in it's the variance. It's the formula. What other method do we have? You find variance using the formula that we have. We have different formulas for group data and ungrouped data. I'm not sure what you mean by that, Kazan. Linear transformation, I can share with you. It's a simple concept. Let me share with you this link that you can use. Complete syllabus recording, S1 crash course. So firstly, just a quick introduction. You'll find here linear transformation. Representation of data, linear transformation. You'll find this explained here in this video. Okay, I'll share this in the WhatsApp group. It's this video in this playlist, S1 crash course playlist. Representation of data part 3. Okay, linear transformation. Watch this on 1.5x, 2x, you'll understand that. You're unable to solve some questions. Can you tell me which exact questions? And we could just quickly go through them, but be quick. Tell me which exact question you're confused about. For ungrouped data, we have to find mean separately. Let me explain how. Ungrouped data for finding interquartile range. Okay. For ungrouped data, interquartile range has to be calculated exactly using this method. You first find the median. So let's say you've got these 11 values. What you do is you first find the median. For these 11 values, 20 is the median. Now this median divides your data into two parts. One to the left of it, one to the right of it. You have two parts of this data. Find the medians of those two parts. Median of the left part, median on the right part. Median of the left part here is 5. That's the lower quartile. Median of the right part is 31. That's the upper quartile. So lower quartile is 5, upper quartile is 31. Find the median that divides your data into two parts. Find the median of the left side, find the median of the right side. They are going to be your lower quartile and upper quartile. Okay? You cannot use formulas here. You cannot use formulas here. They do not work for ungrouped data. If the median is like this, if you have an even number of values, median is going to be the average of 20 and 25. So the median is 22.5. The data on the left side would, in that case, be from 2 to 20, all of these values. And the data on the right side would be 25 to 60, all of these values. Find the median of these two halves of the data. Median of the left side is going to give you upper lower quartile. Median of the right side is going to give you upper quartile. Okay. For ungrouped data, this is the exact method you have to use. If you use formulas, sometimes you end up getting wrong answers. That's not acceptable. Okay, all right. So let me know about the difficult questions that you're talking about tomorrow then. Tomorrow is Saturday. Tomorrow we want to do 2 papers. Yeah, okay. Let me know after tomorrow's class, okay? For representation of data, are there any formulas that we have to remember other than the given formula sheet? For representation of data, you have to remember the median formula, n plus 1 over 2. For ungrouped data, so it's just about median, upper quartile, and lower quartile. There are no other formulas as such that you need to remember for them. All of them are given in the formula sheet. For representation of data, you don't need to remember anything else. For histogram, you have to calculate frequency density. You should know frequency density is calculated as frequency over class width, right? And then what other formula do you have? There are no other formulas really. Just the formulas for median, lower quartile, and upper quartile. Ungrouped or grouped data sometimes. Nothing apart from that. Okay. For finding midpoints from tables, well, again, if you have data like this, 10 to 20, and then 20 to 40, and then maybe 40 to 70, just add the numbers up, divide them by 2. 10 plus 20 over 2, that's 15. 20 plus 40 over 2, that's 30. 40 plus 70 over 2, that's 55.5. Right? So just have to add the numbers, divide them by 2, find their average essentially. Okay. What I'll do is I'll try to make some videos for the difficult questions like we did for M1 and P1 as well. So maybe some of the questions that you are thinking of, they might be answered in those videos as well. So using all the papers that we've done until now, 2020 to 2024, what I'll do is I'll make some topical videos for the difficult questions from each topic. I'll try to work on that tomorrow, I guess, and then overnight we should have all of them available, hopefully by Sunday morning. Maybe some tomorrow and then the rest on by Sunday morning. You can have a look at some of them as well. Just skim through them. If there's any question that you do not understand, you can get you can see the explanation for that there. Okay, so I guess that's it then. Nothing else. This paper is complete, right? We haven't missed anything. Yeah. All right, good. So that's it for today. I'll see you again tomorrow. Allah Hafiz.